So this is a 5-part video. It's quite long, so bear with me, and then you can skip to the other parts if you have already if you think you know this part, to the later part of this video, and I will be erasing the solution to each earlier part after I completed it, so you jump back, right? Okay, if you want to see the earlier part of this video. So now that the first part is ask us to sketch all the XR intercept with the C with all axis intercepts and the endpoints clearly. So endpoints and axis intercepts must be sketched clearly. So this is drawn using GC. So if you want to use GC to draw this, okay, you go to the GC and then you try using the mode. You must make it change it into the parametric mode first, right? After you go to the parametric mode, and then after you go to y equals to key in the parametric equations of the x and the y, and then you go to window. Make sure this is actually minus 2 pi. I key in minus 2 pi and enter, and then you change to this, and this is 2 pi, okay? And I didn't key in this number. I just key in 2 pi. Alright, okay, and then it got me this string of numbers, and the scale I set to 1 1 so that I can see from the graph what is the number. So this is my settings, right? So I could go to the graph then, because I set the scale to 1, right? Then this means that this point is 2 and this point is 6 point something, and this is the graph that I obtained. That's why you see. That's why you see the graph here. So I got my 2. This is easy to see. So when my y is 0, then my cosine theta is minus 1. Cosine theta is minus 1 means my cosine theta is equals to minus 1 means my theta equals to what? When is cosine theta equals to, no, y is not 0, y is 2, sorry. So x is the 0. Okay, so x is 0. So when x equals to 0 minus sine 0, then you give me 0. So my theta is 0. Okay, so cosine 0 will give me 1. So y equals to 1 plus cosine 0. So cosine 0 is 1. So I get 2. So 0, 2. This point corresponds to that theta equals to 0, okay? But x is also 0 at the same time. It's happen to be, okay? Not always the case. So then for this part, minus 2 pi, okay, I suspect this point to be minus 2 pi, so I insert the minus 2 pi, so I get x equals to minus 2 pi minus sine minus 2 pi. And I know that sine 2 pi is just, or sine minus 2 pi is just 0, okay, because the sine graph is like this, right? This is 2 pi and this is minus 2 pi, and they both rest on the okay, they both as y equals to 0. It happens, right? So this point is my minus 2 pi, and minus 2 pi substitute inside, you get, yeah, we get this, you get equals to what do I get when I substitute? So x equals to minus 2 pi, and minus 2, this one is just 0, so I get the minus 2 pi. So if theta is minus 2 pi, so I substitute the same minus 2 theta equals to minus 2 pi into this equation. I get y equals to 1 plus cosine minus 2 pi, and cosine minus 2 pi, you see the graph of cosine is like this. So when cosine is minus 2 pi, my cosine minus 2 pi is equals to 1. So equals to 1 plus 1 equals to 2. So it fits the case that this is y value 2 and x value equals to minus 2 pi. So this part corresponds to my point theta equals to minus 2 pi. And you can prove that this part is theta equals to 2 pi using the same method as well. And my x is equals to 2 pi. Okay? So that's it for the first part of the question. I labeled except there's this part as well. So when y equals to 0, that means 0 equals to 1 plus cosine theta. That means my cosine theta equals to minus 1, and my theta would be, when is my cosine? It could be is pi, right? Okay, so when it's pi, my cosine theta equals to minus 1. So my theta is equals to pi, right? And it yeah, so this is pi. And same case, it happens also when it is minus pi. So this part is minus pi anyway, right? And this is the minus pi when x equals to minus pi and when x equals to pi. Happen that theta also equals to minus pi and theta also equals to pi at this point. Not always the case, right? But let's see. Okay, then once you have done that, right, this theta is actually not necessary. I'm just showing you, right? You just need to label the x and y axis in the step. So for part 2, using the fact that C is periodic with period 2 pi, or otherwise find the exact area enclosed by C, the lines x equals to minus 2 pi and x equals to 2 pi, and the x-axis. That means for part 1, the area that they want is this area under this graph. So to find this area, of course, we used our 0 to 2 pi. Okay, actually we want from what, minus 2 pi to 2 pi, right? And then the graph of course, the graph of y dx, okay, dx. But this is difficult to integrate. Let's say if you even change it to in terms of the Cartesian equation and then you integrate, is quite difficult. So we use the parametric method. That means changing everything to integrate with respect to d theta. Okay, so y is just but okay, I know that this part is symmetric. Okay, so instead of integrating from minus 2 pi to 2 pi, I could make it neater. So I integrate from 0 to 2 pi and then multiply by 2. Okay, this is the method. So then after that, y I just change to okay, so now this is the part, right? My y I change to 1 plus cosine theta. Okay, and then I need to integrate with respect to theta, right? So how do I get dx? How do I get dx, right? Okay, so dx I get in terms of theta, I get from here by differentiating the parametric equation of the x. I get dx d theta equals to 1 minus cosine theta. Okay, and so dx is equals to 1 minus cosine theta whole thing times theta, right? Common mistake student made is to omit this bracket, right? Then when they substitute back into here, they omit this bracket, and that's the problem, right? But now, okay, so if I've gotten dx and I have this, so this one I'll substitute back, I'll get 1 minus cosine theta d theta. Another common mistake student made is to forget the bracket here. Okay, 1 minus cosine d theta is going to multiply to the whole thing, not just to the last term. Okay, so then I got to this. So once I got to this, but I still need to determine what is my, just now was in terms of x, so x equals to 0 and x equals to 2 pi. Now we want it in terms of the d theta, right? But happens that from 0 to 2 pi, okay, my theta is also 0 to 2 pi. So therefore, I change it to 0. Not always the case. You always actually need to change it, right? Using this equation, if you need to change in the x values to express, to get the theta values, and then you substitute inside here. Okay, so then we can begin to do our integration. So we have this equals to 2 integrate 2 pi to 0. This is a plus b, a minus b equals to a square minus b square, if you remember. So you get 1 square minus cosine square theta. Okay, 1 square minus cosine square theta, which is just 1 minus cosine square theta, which is just sine square theta. Using the trigonometric identity, cosine square theta plus sine square theta equals to 1. Okay, so we rearrange the 1 minus cosine square theta give you sine square theta. So now I'll change this part to sine square theta. Okay, sine square theta d theta. And then there's another, we don't know how to integrate this, so I'll just use the trigonometric identity, cosine 2 theta equals to 1 minus 2 sine square theta, and replace sine square theta with sine square theta is actually equals to 1 minus cosine 2 theta over minus 2, which is equals to, actually it is equals to cosine 2 theta minus 1 over 2. I write it this way. Okay, so if I change it to this and then I substitute inside, the 2 and the 2 would cancel off, so I'll left with 2 pi 0 cosine 2 theta minus 1. So constants can be bring out of the integral sign to here. So then cosine 2 theta minus 1. So after that, when I integrate cosine 2 theta, when I integrate, it becomes sine 2 theta over 2. Okay, and this one becomes minus theta, and then I get this 2 pi 0. So I substitute this inside. So 2 pi becomes 4 pi. Sine 4 pi is still 0. Okay, so 0, then minus 2 pi. Okay, minus 2 pi, and then I minus, so substitute 0, sine 0 is still 0, minus 0. So I get something strange. Let me check. Cosine 2 theta minus 1 minus cosine 2 theta. Oh, okay, I made a mistake over here. So while I was taking cosine 2 theta, I bring over. So this minus 2 I bring over, then I divided by, I should divide by 2, right? Not minus 2, and then this would be 1 minus cosine 2 theta over 2. That means my sign is inverted, right? So it should be 1 minus cosine 2 theta. Okay, 1 minus cosine 2 theta, and then this part I get theta, so this part should be plus, and this should be minus. Okay, so then I have sine 2 0 minus sine, okay, minus, then plus 2 pi, and then 0 0. Okay, so I will end up with 2 pi is my final answer. So I got the for this part, I just made a mistake over here. So be careful, okay, of such simple algebra. It can cost you marks as well in the exam. So now that I have done this, I want to go to the second part of this question, the third part of this question. So for the third part of this question, I don't want this area anymore. Okay, I don't want this area anymore. The area that I want is, okay, they say that the C is for x smaller equals to theta and to 2 pi. So theta between pi and 2 pi, that means the curve is just this part. Ignore this part, there's no more this part, so it's just this part. And the region bounded by this C1 is just here, the axis, okay, and the line y equals to 2. Right, so that means we want the entire area over here. So natural thing is we want to integrate with respect to the y-axis. So I will integrate with respect to the y-axis from 0 to 2. Okay, 0 to 2, and then in terms, then the y, we want to integrate the x and with respect to dy. Okay, so get this first. Okay, so but when y equals to 2, it corresponds, let's say if I want to integrate now with respect to d theta, I want to change everything to d theta. So 2, when my y is 2, my theta is 2 pi, and my y is 0, my theta is pi, and my x is just theta minus sine theta, and dy, what do I get? I use this parametric equation, dy d theta equals to, in the differentiate 1, get 0, differentiate cosine theta, I get minus sine theta. So dy is just equals to minus sine theta d theta, so I replace dy by minus sine theta d theta. Again, don't forget this bracket is very important, and this bracket, so minus sine theta, okay, d theta. Okay, so then here we have this equation. We will have equals to integrate 2 pi minus theta sine theta and plus sine square theta d theta. Okay, I will integrate each of these parts separately, and you will see what you get. For this part, right, is similar to what we have done just now. So integrate from pi to 2 pi sine square theta d theta. Okay, so I just make use of this identity again. Okay, this time I won't make the same mistake. Okay, so this bring bring over, so I get 2 sine square theta over here equals to 1. This bring over becomes 1 minus cosine 2 theta, and the 2 I bring over to this side. So my sine square theta is just equals to half. The half I will bring outside of the integral to make it less complicating and less complicated. So 1 minus cosine 2 theta d theta is over here. Okay, I didn't make any mistake, right? Just check. Okay, so equals to, then after this, when I integrate, I get half. Okay, then integrate this part 1. When I integrate, I get theta. When I integrate minus cosine 2 theta, I get minus sine 2 theta. Don't forget to divide it by the differentiation of this 2 theta, which is 2. Okay, so then I have this 2 pi from here and pi from here. What this means is just that, okay, this 2 pi you substitute inside here, so 2 pi minus sine 2 pi minus sine 4 pi. Okay, minus sine 4 pi is just 0. Okay, so 0, then minus, then pi, and I substitute inside. Okay, I get this, and 2 pi is just 0, so minus 0, so it's still pi. So this part I get 2 pi minus pi is just pi. So this, for this part I just get pi over 2. So I have settled one part, which is pi over 2. I'm now left with this part, 2 pi theta sine theta. Okay, this negative sign I have bring in front. This pi over 2 is just this integration. Okay, so then now that I have this, I just need to integrate this part. I'll just erase. So I would just like to tackle integration part by part. I don't like to write long workings, long stretch of workings. It's very easy to get mistake when you do long stretch of workings. So here I'll just integrate this part. Okay, and ignore the negative sign for the time being. So theta sine theta. Okay, d theta. So if you don't want to keep writing this part, you could also just integrate this without caring about this. Then later on, when after that, you just substitute at the end, very end. I'm just going to do this. So remember LIATE. Okay, this one is algebra. Okay, this is the priority to on which one to keep for when you do integration by parts, right? So this is trigo. Trigo is after algebra. So this is algebra, this is trigo. So trigo is after algebra. Therefore, when I use integration by part, I will keep the algebra and I will integrate the trigo. So when I integrate the trigo, what do I get? I get minus cosine theta. Okay, so this part settled. I will just put 2 pi over pi here. Then after that, I will minus the integration of, okay, this one pi to pi. Okay, and then this minus cosine theta I will bring inside. The one that I have integrated, I will bring inside it, and then I will differentiate this theta, which is 1. So differentiate theta is 1 here, so I just make it for clarity's sake. Okay, then here this one minus and minus would become a plus, right? So plus. So I simplify. So this part I will substitute in. So I get what is cosine 2 pi? Cosine 2 pi is just 1. So this one will become minus 1. Minus 1 times 2 pi is minus 2 pi. Okay? So we have it here. So then the next part, pi. Pi is minus 1. Okay? Cosine pi is minus 1. Okay, minus 1 times minus is plus 1. So plus pi. Okay? But no, be careful. So we have it. If you can't, then we do it slowly. So 2 pi. Okay, then now we need to negative minus the pi. Cosine pi is negative 1. So negative 1. Write it this way. So if you can't do it fast, then you do it this way. So this one is plus, right? So minus 2 pi minus pi. So this would give me minus 3 pi. So there is a bit of confusion, so I want to double check here. So 2 pi 2 pi substitute inside, I get 2 pi. Okay, cosine 2 pi is indeed 1, so minus 2 pi. Okay, so minus this part is pi. Okay, cosine pi is -1, so -1 times +1, +1 times pi is +pi. But because this is the second term, so we have the minus pi. So okay, I get minus 3 pi for this part. Okay, so I'm going to change it to minus 3 pi because I'm erasing all my working, so I cannot check back, so I better be clear every step of the way. So this one I will add to this, and this is just integrating cosine theta. When I integrate cosine theta, I get sine theta. Okay, so sine theta from 2 pi to pi. So did I get it correct? So pi to 2 pi, yes, pi to 2 pi give me, okay, can. So 2 pi, so this part is just minus 3 pi plus, okay, sine 2 pi is just 0, sine pi is 1. So wait a minute, so sine pi, okay, correct, yeah. So sine pi is, sine 2 pi is 0 and sine pi is 1, so 1. Wrong. Sine 2 pi is 0 and sine pi is 1. So I have it here. So minus 3 pi minus 1. Okay, that means this thing, the entire thing is minus 3 pi minus 1. So I have equals to pi over 2 minus 3 pi minus 1. I'm actually quite surprised. Wait, sine pi is 0. So I made a mistake here. Sorry, sine pi is 0. Sine 2 pi is also 0 and sine pi is also 0. So this is 0 minus 0, and here we will have minus 3 pi. Okay, that's my mistake again. So here when I substitute back, this whole thing is minus 3 pi and there's a negative inside. So I would have 3 pi plus pi over 2, which is equals to 3.5 pi. So I gotten the answer here. Okay, so now that we have done the first 3 part, I'm going to the 4th part. Alright, I'm just going to erase it away. Okay, it's for a long question. Just have to be careful. Okay, every part. Right, so then now find the volume of the solid when it's rotated 2 pi about the y-axis. That means this solid is rotated when R is the region bounded by C1. So is this region that is rotated about the y-axis. So it's rotated about the y-axis, right? So then what do? We will integrate. Okay, pi and these are the x values, so x squared. Okay, pi x squared. Then the first, as usual, just like just now, we will have 0 to 2, and we will do it with respect to dy because we are rotating about the y-axis. Okay, so for this part, if we will have equals to, now I want to integrate with respect to d theta, then what do? I just change everything in terms of d theta. So it will be similar to just now, but let's pause to see if there's anything that I can do to simplify this note. Okay, so I'll change it. So 0 of the y is like the pi of the theta. Okay, so 2 of the y is like the 2 pi of the theta. Okay, so then the x squared is just theta minus sine theta square. Okay, and my dy, like just now, dy d theta is equals to minus sine theta. Alright, and that means I must multiply minus sine theta d theta, okay, to replace my dy. Okay, now everything in terms of theta. Alright, and see if expansion works. Okay, haven't tried this question, so not sure, but let's try. So think along with me. So theta, so when I expand this, I'll get theta square minus 2 sine theta plus sine square theta. This is just my quadratic expansion. Then I multiply minus sine theta and d theta. Okay, then when I do this, I need to multiply inside again, so I get minus theta square sine theta. Seems quite complicated, so minus 2 sine, no, plus 2 sine square theta, okay, then minus sine cube theta d theta. Alright, I'm beginning to think that perhaps it is a bit complicated to differentiate in this way. What if I change it to, is there any other way to find this volume of the solid? It's quite, you could of course use the graphical calculator to do this, but let's sort out the concept first. Forget the integration first. Okay, so for part 4, at least we know that, okay, if you key into the graphic calculator, and that's, but even if you key into graphic calculator, you need to sort out what is your x squared. Okay, you can key in all this expression inside the graphic calculator, you would get the, you'll get the value. Okay, so what, that's it. But if I don't use the graphic calculator, so let's deal with part 5 also first to sort out the, so what is the volume of solid when r is rotated about 2 pi radians about the x-axis. So the same region, but it's now rotated about the x-axis. Okay, so what I can do is I take, okay, since this is a rectangle, right? So if you look at this part, it is a rectangle. So if rotated about the x-axis, I get a cylinder. Okay, if that is a cylinder, okay, so I can just, with the radius is 2, so would be pi r square. So the cylinder is pi times 2 square, pi r square times the height. The height here is 2 pi. Okay, the height here is 2 pi, the base area is pi 2 square, which is pi r square, and then that's the volume of the whole cylinder. But I need to minus away this part. Okay, I need to minus away this part, so the volume generated when I rotate this part of the curve about the x-axis. So I know that this part actually stretches up to this point where they touch the x-axis, so I want to minus away pi, integrate from pi to 2 pi. Now I want to integrate with respect to the y, right? With respect to the x. Okay, with respect to the x from pi to 2 pi. So my this inside should be the y square. Okay, square, because we are now finding volume. We always have this pi and this y square when trying to find the volume. Okay, so then if that's the case, we have 4 times 2, 8 pi square. Okay, 8 pi square, then minus pi, then pi 2 pi, and my y is just one thing, no, oh yeah, correct. So then we know that pi of x, it happens in this question, theta is also equals to pi, and when x is 2 pi, theta is also equals to 2 pi. So I just write it like this. So y I change to 1 plus cosine theta whole thing I squared. So dx I'm going to change it to d theta as, so dx theta d theta equals to, looking at this parametric equation, I get 1 minus cosine theta. Okay, so dx is equals to 1 minus cosine theta d theta. Okay, so I'm supposed to integrate this expression to get the answer to the fifth part. Okay, so minus away this, so that means the cylinder, minus away this, I'll get the volume generated by rotating this part about the x-axis. This is the second part of the question. So let's say I will try to use the GC first to confirm that the answers, okay, and then after that we explore ways to integrate this kind of expressions. Okay, but that may take long because I haven't thought of a way to integrate this expression first. Maybe we need to change this to a Cartesian equation first for easier integration. I don't know. So let's try. Okay, so let's minus theta square sine theta 2 sine square theta minus 3 sine cube theta minus sine cube theta. Give me a minute. I write down this expression somewhere, then I'll show you how to use the graphic calculator to do this. Okay, and give me a minute. Okay. In fact, you can actually fast forward the video while this one is I'm waiting. Of course, you don't have to wait. Or you can use this time to try integrating without the GC. Yeah, I'm just taking the pictures to help me when I switch the screen to the calculator on my tablet. Right, so how do we do integration? We just go to math, alright, and then this Fn stand for function int stand for integration. So I press function integration. Okay, let's do for the fourth part first. Okay, if this is the fourth part, right, we have pi. Okay, that doesn't matter that the pi is in front, so we could go second insert. You see, we can insert a pi over here or not, and second pi, right? Yeah, indeed, we can insert a pi in front to simplify our so then second pi. Okay, this was our earlier expression that I found. So 2 pi. Okay, and here the expression is actually doesn't matter pi or x, right? Just I keep minus, so minus x to the power. Oh, this is a parametric mode. Can I change to actually? I think doesn't matter. Okay, so minus t square. Okay, then sine t. Okay, go no, you shouldn't go there, so just close the bracket and plus 2. Okay, your sine square theta, so sine t, I want to the whole thing, I want to square the sine t, right, plus 2 sine square theta. I type it in this way, right? Oh no, so I just go down first, press, nope, delete away this minus sign, go down first by pressing the right button and then press minus. Okay, sine cube theta, so I will do open bracket sine t close bracket and cube it instead. Now this is a long expression, this go here, d theta. Okay, see if we get the correct answer. This is enter. I get 156.52, which is obviously, is it the same as what we get just now? Nope. Pose some problem. Let's see. No, cancel. I don't want to discard this. Could be some calculation error. Let's check. So when this happens, you have to check your working and see what is wrong. We have minus theta. Just enter again to get the expression. But be careful when you do enter again. There's no answer in front. Okay, so pi multiplied by pi 2 pi. Okay, just check whether my computation is correct first. Then if not, then I go back to check the working. So sine t plus 2 sine t square minus sine t cube dt. Not wrong. Okay, so check earlier on. Minus sine theta plus minus is up to that step is correct, and theta square minus 2 sine. I got my mistake. It should be, okay, go back to my earlier working. I made a mistake here. No, go back to my earlier working. So I made a mistake here. When I do the expansion over at this side, is theta square minus 2 theta sine theta, not just 2 sine theta. So this kind of mistake is costly in the exam if you don't have the answer to cross-check. So then plus sine square theta minus sine theta. So then we have theta square minus, that means there must be another theta over here. Okay, so I'm going to erase it. 2 theta sine square theta. So 2 theta sine square theta. Having found mistake in one part, actually you should be careful to check this expression. In fact, if you're keying into the graphic calculator, actually you don't need to waste time with this expansion. You straight away key in this part. It would be it will save you a bit of more time. So anyway, I'm going to add a theta back in here. So where should I insert it? I could insert it behind or in front, but I'm choosing to insert it here. So second insert, and I'm going to key a T here, and then I get, okay, 2 theta, and then I'll try this expression again. I press enter. Do I get the correct answer? 193.163. Okay, let's go back and check. 193.163, is it the correct answer? So 193.163 round off to 1 decimal place is 193.2 units cube. So we got it. So it's just okay. By the way, the answers are thanks to Raymond Ng from, I got this question as well from YouTube, and there are a few tutors actually sharing their ideas, and they got the answer, and so I'm just presenting it in a video format for you to understand. Okay, so then the other part of this, find the volume of the solid. So I'm just going to key this inside the graphic calculator again to see if I can get the answer to the fifth part of the question. Okay, so now I'm going to key it in. So I go back to the graphic calculator, and then I'm going to key 8 pi square. Okay, you can also key this button instead, right? But no, so I'm just going to delete it. Yeah, okay, 8 pi, delete it. Yeah, okay, delete it. Yeah, okay, 8 pi square, and right button minus, then after that you have the pi, then after that I will do the integration sign, maths function integrate. Okay, and bottom I'm going to lower limit, I key in pi, upper limit. In fact, you don't have to look at me doing all this. You could try it out on your own calculator, unless you don't know how to do it. So that's just 1 plus cosine theta, so cosine t. Okay, then the whole thing would, no, here I'll just close a bracket, and then I'll just close bracket again, and I'll square. square the whole thing. So I'm squaring the 1 plus cosine theta, the whole thing, okay? And after that, I'll open up again. So 1 minus cosine t. Okay. Perhaps we got the cue that we can use a graphic calculator because there is just a few marks given for this question, and at the same time that the expression is a bit too complicated. If it is a purely integration question, of course you can't use the graphic calculator question, or just integration techniques, of course you can't, but this is actually testing you how to form the integral and to find a solid. So therefore I think the integration part of it would weight less. I hope you understand what I mean. So then I press enter, I'll get another value 74.022. I hope that is the correct answer. Okay, so 74.02 units cube. So indeed we got all the answers. Okay, then so that's it. So there is also a side discussion on that YouTube, that what if you got something like this, okay, and you're asked to find, you get a sine theta. This is your y goes to sine theta. Alright, what if you are to find they are asked to find the volume of solid over this part, right? This part. If this part is rotated about the y-axis, how would you find this? Okay, the question is actually quite good, and in fact you can change this to axis to theta, so then it's just is simpler. Okay, so this one is of course 1, since it's 1 goes to sine theta, then this part would be pi over 2. Okay, so to find this, in fact we can use the same idea, the cylinder, because there's a cylinder here, radius pi over 2, so I'll have pi, the cylinder, right? It's just calculating the volume of the cylinder. If I rotate this rectangle, okay, over the y-axis 360 degrees, so it will be pi r square, means the circular base times the height times 1. Okay, cylinder, then after that minus inside the volume inside. So how would I will minus from integrate with respect to, of course with respect to what? With respect to 0 to 1 and my theta, which is my sine inverse y square. Okay, that is a problem because that's a problem, because if I need to use sine inverse, because if here the problem is, let's say if you use sine inverse y, and then you are going to get this problem d theta, and we don't know how to integrate something like this. Okay, what method could we use to solve this question? You can switch off the video now. In fact, I'm just trying to think of a way. I might be able to think of it, I might not be able. So what if we do something simpler? If we find this area instead, integrate with respect to y, and all this is in terms of x. But what if we integrate with respect to this but the solid generated, wow, yep, that's quite tough to say, yeah. You still need the sine inverse y square d theta. But if you can use the graphic calculator, then it wouldn't be that difficult. But why sine inverse? Oh, actually, it's not as difficult as it seems. Okay, because integrating with 0 to 1 and respect to what square? Sine inverse. Nope, I need to check this part again. So minus the, okay, this volume generated by rotating is the pi 0 to 1. Okay, the x value, so is the theta, okay, and respect to y, so dy, and theta is just theta square, so theta is just sine inverse y, okay, so sine inverse y whole thing square d theta. But think of it, your y is just sine theta, so your sine inverse y is just what? It's just, no, we are integrating with respect to what? 0 to is with respect to y. Okay, so that's the problem, right? What if we change to integrate with respect to, no, to d theta? If we change to integrate with respect to d theta, then we'll have, can we? Okay, try. So pi, so when y is 0, x is, theta is 0, okay, when y is 1, theta is pi over 2. Then sine inverse y is just my theta square, and dy is just dy d theta is just equals to cosine theta. So I will get cosine theta d theta. I change it to integrate with respect to theta. Do I get it? Well, okay. This one I will need to do some confirmation, 0 to 2 pi, and I need to do some confirmation with other teachers. So meanwhile, that's it. I will give any updates on the description of this YouTube video.